Hey there, everyone. My name is Ryan Schul. Welcome to my analytics channel. So, in the topic today, I want to take a look at analyzing Yahoo Finance using real-time anomaly detection, and we're going to use isolation forest, all right, to try to find these anomalies, right? So, isolation forest is basically an unsupervised machine learning algorithm for anomaly detection. It works by isolating outliers from normal data points. So, it's not just, is the stock price going up or is it just going down or is it just going sideways, but it looks at the pattern of the data. So if it's mostly sideways, for instance, then all of a sudden it ticks up, that could be considered an anomaly. But if it was trending up, that wouldn't necessarily be an anomaly, okay? And vice versa, if it's trending down, that wouldn't necessarily trigger an anomaly flag to be set. But if it was down and then spiked up, that could be considered an anomaly, right? So we just look for patterns and trends and look for something that doesn't match that pattern and trend. That becomes an anomaly, okay? So hopefully that makes sense. It's not just up, it's not just down, it's not just sideways, but it's the shifting in patterns, so the changing in patterns. That's what we're trying to detect here. And by the way, this is not going to be a trading tool by any means. All we do is look at the stock price changing over time. In this case, I'm looking at Microsoft. Here's the ticker right here, MFST, and you can put whatever you want in there, right? So it could be Apple, it could be Tesla. We're looking at 1 minute intervals, okay? And just fetching the data every 1 minute. I think you could, I don't even know if you could get real-time data. If you look at Yahoo Finance, they do report in real time the stock price movements, right? I'll show you in just a sec here. We can see Microsoft moving in real time, but I think they only let you fetch as frequently as 1 minute. I don't think you can get more frequent than that. But they're on their system, they are feeding you real-time data. So let me see how we get this. Boy, this thing is a little bit slow. Okay, here we go. We got something. Okay, so here's the intraday data. We have 1 day of data. Let me get rid of this thing. Okay, you can see it flash right there. So they are releasing, it looks like maybe 5-second to 10-second intervals, but I think there's a lag too, okay? You have to kind of look into the documentation and dig around a little bit to find out exactly how this stuff works. I think there is a small lag and it goes by up to 15 minutes, depending on the stock ticker. I don't want to misspeak and get the wrong information, but something like that. You can Google it and look around. So that's the premise for the for the study here, for the experiment I'm running. And again, this is not trading data. I have tons and tons of videos on my channel about trading, and I'm never making financial recommendations to you guys. I'm just showing you the mathematics, the statistics, the computer science, the finance of how this stuff works. Okay, so if you want to take the information and use it for trading, potentially trading on it, that's really up to you. This is not a recommendation. Okay, so in this first case, I run the code. I just want to see what the data frame looks like. So this is a multi-index. You can tell because they have an index inside of an index. Or what is it? This looks like it looks like a tuple. It looks like a list of tuples here. I think that's what that is, because the square bracket indicates a list, and this is a tuple, right? So I think that's how they're getting that. And I think they changed this recently. Like, I don't remember this a long time ago. I think about a year ago or so, they kind of went to this multi-index kind of structure. I'll call it data structure. Before that, it was pretty straightforward. You just had your price ticker, close, high, low, ticker symbol, date, and things like that. So I think this changed a little bit. So anyways, you can see I ran this a little while ago, and it's actually running now. So I'm not going to rerun this. You can see by the little hourglass in the upper left-hand corner, this Jupyter cell is actually running. So I'm not going to rerun it, but you get the date and the time down here. It's updated in 1 minute intervals. And again, you can go ahead and get the ticker that you want and the frequency that you want. Okay, so 2 minutes, 5 minutes, whatever. It's really up to you. It's kind of an arbitrary frequency, 1 minute, but I think that makes sense in this case. So in the first cell, all I'm doing is just running this code just to see what the data frame looks like. So that is it. We can tell it's multi-index, right? And we can have the last 5 minutes of trading history. Now, when I run this one below, it's going to continuously run in the background and fetch the data. So we need about 20 minutes of data to train the the isolation forest model. We need about 20 minutes worth of data. So it has to run for about 20 minutes, and you can see it's building up the information down here. These are called bars. So bar is delivered once per minute for 20 minutes. After 20 minutes, we have enough history to start making recommendations about whether or not this stock price is going to be labeled as an anomaly or as not an anomaly. Okay, so when you run the first cell, I'm not doing this because this is running in real time, and it'll lose that 20-minute build up to get the history. The first cell just shows you the data frame. The second cell shows you the data frame just for peace of mind, so you know how this is working. You can see the ticker, you can see the dates and the times down here. Then again, every 1 minute it's updated. So the last one was running at, let me see here, now it's 1417. Okay, so it's 217 or 218 now. So I should get another one pretty soon here. And the date is 10/3, right? So October 3rd, 2025. And that is evidence over here, 10/23/2025. And there's the update. So 2:18 p.m. in New York City right now. Okay. So how do we get here? Let me take you through some of this code. So we go ahead and make the fetch of all the history to Yahoo Finance, right? So we're looking at this in real time. This is running in 1 minute intervals, right? We go ahead and fetch the Yahoo data that comes from right here, right? We get the ticker and 1 minute intervals. I just showed you that. We're getting the time and the date set to Universal Time Code. I think that's called UTC, and this is New York. So we're getting the format for New York City, 24-hour format. I think it's totally fine. We don't need like the 2 p.m. and the 1 p.m. and all that stuff. So we have the open, high, low, close, adjusted, close, and then the volume of trades, or what is it called? Volume of shares that are being bought and sold, right? So you get all that information, feed that into the isolation forest model, which is down here. Okay, I'm doing a couple of things over here to go ahead and iterate over all the items in the row. So this is all the items in the row of the data frame. And then the isolation forest comes from down here, right? So if I do Control F, you can see the number of estimators right here is one parameter that I'm feeding in there. So you can change this to be what you want, right? Contamination is set to auto and random state is set to 42. This is just one way to set this up, right? You have a couple different parameters that you can test. I'll leave it to you to go ahead and figure out what's best for yourself. But again, we're looking for these changes in stock price movement over time, and we're trying to detect, is this an outlier or is this not an outlier? If it's an outlier, then the tool is going to indicate that and it's going to report that. If it's not an outlier, and for something that like Microsoft, that's pretty liquid and pretty much trading all day throughout the day, I don't think you're going to see these big spikes for this type of stock. But if there are some, then this isolation forest model will pick up on that. So where does it actually get all this information from? It comes from right here, XS. If I do Control F, you can see we are calling the model right here. Okay, so assigning the model and then fitting the model right here. And this XS comes from X minus mu divided by standard deviation. So this is a standard way to get a z-score. X would be the average value, mu would be the mean. Okay, I'm sorry, I said it wrong. X would be the data point, mu would be the mean, and you divide by the standard deviation. So that is pretty standard for getting a z-score. If you don't understand what that is, go ahead and look that up. I would encourage you to do that. There is a little math behind this, right? But it's nothing really crazy or really super advanced, right? Like you can Google all of these things and you can go ahead and figure out how this works pretty easily. And by the way, I'm going to share all this code with you guys, right? So you can run it for yourself. So again, the first cell that I showed you is just going to show you the data frame. The second one does all the isolation forest analysis and then prints out the results right down here. Okay, so we can get the results updated in 1 minute intervals, right? Here's the return. Here's the range that it runs within. Here's the volatility of the z-score. Okay, and then here is the isolation forest score. So the model is doing the scoring and it's showing us the z-score as well. So I have some notes down here. You can read about this. And again, if you don't understand what this means, I think this is a great opportunity to do some Googling, put some ideas into Chat GPT and see what you can come up with. The Z-score is a very common way for looking at um, something that could be statistically an anomaly or very similar to the peer group and then considered not an anomaly, right? So if you want to change this threshold, you can definitely do that too. So I put in another feature over here where you can test or change the threshold to try to force this to be an anomaly, right? So it comes from right here. So you can say something that's a small price movement to you, that could be anomalous, right? So that's something that you want to control for. That's something you want to change. You can go ahead and set that threshold right there. I think 0.25 is good for for the illustration purposes here, but if you want to change that, by all means, you can do that, okay? So what else can I say about this? So we're looking at changes in z-scores, right? That's going to be indicative of an anomaly, or there's nothing unusual here, right? Those are the two outcomes. There's nothing really in between. We want to see alerts. We can change that threshold. You can make it a little bit lower, 0.15. If you change that to 0.15 and lower that, then you'll probably have more hits over here, and there's going to be more anomalous scores, right? Because this threshold now is smaller. Theoretically, and then you're going to have more anomalies over here, okay? So again, this is not a model for trading. If you look on my website, I have a bunch of models for predicting future stock prices, for looking at different trading strategies, see what strategy performs well over time, see which is profitable and which is not. This is really a different approach to analyzing a stock's price. We're looking for outliers using the isolation force technique, okay? So that's what the model is for. So don't misinterpret that, please. Isolation force is basically unsupervised and detects rare behavior, not whether a price will move up or down. Okay, so again, it's looking at the current price in real time, comparing this to the peer group, like what has happened in the history. You can see this is 2:23 p.m., 2:22, 2:21, 2:20 p.m., and the market's going to close at 4 p.m. Okay, so we're just looking at rare behavior in stock price movements in real time over the course of time. That's what it is. It's not a signal for trading. The stock is moving up or moving down. It's not like that, right? So you have to treat it more like a smoke alarm, right? It's warning you. It's saying, hey, you need to pay attention here. Something's moving, but it doesn't indicate like the direction of the price. Is the price going up? Is it going down? I mean, you can look at that and you can determine that for yourself. But that's not what we're trying to do. We're looking at the behavior of the price and how rare it is relative to how it performed in the past. Okay, so that was it, guys. I will save this model. I will share that with you when I post a video, which will be a little bit later today. You can download the source code and you'll have everything you need to run it in your own Jupyter Notebook environment. And by all means, Google it. If there's something that you see here that you don't understand, ask ChatGPT. These things are your friends, okay? And just have fun with it. So that's it, guys. I'm going to wrap it up here. Thanks for your time, and I will see you in the next video, which I should be dropping pretty soon. Take care. Bye.